So in this video we're going to have a look at how the effects of changing pressure can affect the position of equilibrium. And we're going to have to keep in mind Le Chatelier's principle about opposing the change. First of all, we need to understand what effect the amount of gas particles has on the pressure. So if we think about a reaction, we can count up how many moles of gas are on each side of the equation, and we can look at what that means in terms of pressure. So the example we've got first is when we're looking at the manufacture of ammonia. We've got 1 nitrogen and 3 moles of hydrogen gas, so we can say in total we've got 4 moles on the left, turn into 2 moles of ammonia. And you can see I've drawn a little diagrammatic at the top, so I've got a nitrogen and 3 hydrogens, and then I've got 2 ammonias. Now if you think about these particles themselves and assume that they take up negligible space, when there's more of them and they are moving around in that container, they are going to bang on the sides of that container more, and they're going to increase the pressure inside that box. When there's fewer, then there will be less pressure. So the left is going to be a side of higher pressure. There's going to be more pressure here and less pressure here. What that means is, according to Le Chatelier's principle, if I were to increase the pressure, then we'll have to move to the side that will reduce the pressure, the side with the less pressure, because that's what Le Chatelier's principle says. So we would have to move to the right where there are fewer moles of gas. And if we were to lower the pressure, according to Le Chatelier's principle, it's going to try to regain that pressure. So it's going to move where there's more particles in order to increase that pressure. So we can move to the left and the right. Remember, we're not going the whole way left or the whole way right. We're just moving a little bit further towards one side than the other. So how do you answer these exam questions? You have a look and you say, in this example, there are fewer moles of gas on the right-hand side. And so if the total pressure were to be increased, the equilibrium would shift to the right-hand side. It would do that, according to Le Chatelier's principle, to oppose the change. And why is shifting to the right opposing the change? So shifting to the right is opposing the change because it reduces the pressure, because fewer moles exert less pressure. So we've shifted to the right, and therefore the yield of ammonia, the amount of ammonia present in the equilibrium mixture, will increase. We'll have more ammonia present. So how could we apply that in a different way? Let's have a look at another example. In this example, we've got 1 mole on the left and 2 moles on the right. So there are more moles on the right. So there's more pressure on the right. If the total pressure is increased, then we would go left. And can you explain that using Le Chatelier's principle? So in exactly the same way, we're going to shift left to oppose the change and reduce the pressure because fewer moles exert less pressure. Now in this example, we're not being asked about yield, we're asking about what will it look like now. So remember, it was in equilibrium. There was a mixture of both reactants and products, and we've shifted left. Now a common mistake in an exam would be to say that this would go colourless. Now remember, we're still in equilibrium, so we still have everything present. It would fade. It was a mixture of brown and colourless, which is going to look kind of pale brown. But if we go left, we're going to look much paler. So it's going to go lighter brown. Okay, so we're going to write ourselves a little note about that. It's not going to go fully colourless. Okay, so it's never going to go fully colourless because there's always some NO2 present. We've got our final example here. Let's have a look at our final example. See what you can think about this last one. So in this final example, there are 2 moles on the left and 2 moles on the right. So we've got equal moles on both sides. So equal pressure on both sides. So if the total pressure is increased, the position of equilibrium remains exactly where it was. And therefore any yield or any colours will be unchanged. And the last little note there is just to remind you that this is a question about equilibrium. Do not confuse it. If the question asks you about rate, rate will always increase when pressure increases because there are more particles per unit volume, so more frequent successful collisions per unit time. So this is about equilibrium and not rate.